EE7. We're still in the standard of solving equations with one variable, but our learning target, number 2, is I can give examples and justify linear equations with one solution, infinite solutions, and no solutions. So before the learning target LT1, which had all those sets of equations that we solved, we always had x, or whatever variable we're using, equaling a value, such as 4. Now we're going to learn about when there's infinite solutions. So x is not just one value, it's multiple infinite solutions, and no solutions, which means there is absolutely nothing that x can equal that would make this inequality true. So the first thing we're going to look at is the conditions for an equation to have that would have no solution. So again, this would be where x does not equal anything. It would never make the equation true when you check it. So a couple things. First of all, the coefficients, which are the numbers in front of the variables, have to be the same on both sides of the equation. And also the constants, which are just the numbers, have to be different on both sides of the equation. So as I look at this, I'll give you just an easy example to start with. Let's go 5x plus 12 equals 5x plus 8. So looking at the conditions, first of all, we're going to see that the coefficients, that's the 5's here, the numbers in front of the x value, or the x variable, are the same. And then you will notice that the constants, which are the numbers, are different. Now you think to yourself, why is this a no solution? Well, the answer is because it doesn't matter what I put in for x, because when you go to check this, let's say you think x is 2. So if I plug in 2 here for x, and I take 2 times 5, and I add 12, and I go over here and I take the same thing, because they're the same coefficient, 2 times 5, but I'm going to add 8, well, there is absolutely no way that this value here of 5 times 2, which is 10, when I add 12 to it, or I add 8 to it on the other side of the equation, there's no way they're ever going to be equal. And I could sit here and do this forever and keep adding different values of x in, and there is no way that the values will ever be equal on both sides, because on this side we're adding 12 to the 5x, and this side we're adding 8 to the 5x, and there is no way that they would be equivalent. Another example would be, let's go, so this is my first example. My second example would be 3x plus 8 minus x equals 10 plus 2x. Now, first of all, before you start, you have to simplify or combine like terms here to see how many x's we truly have. So if we look at this side of the equation, I have 3 x's and a negative 1x. Well, that gives me 2 x's. And then when I write it here, again, we're going to notice that the coefficient are the same. And it doesn't matter where they're placed, but the coefficient is 2. So there's 2 x's on this side, 2 x's on that side. And again, we're going to add 10 on this side and add 8 on this side. There is absolutely no way that these two would ever equal each other by placing in a value for x. And the last example, let's go 4 times 2x plus 3, and that equals 6x plus 11 plus x plus x. Ran out of room there. So we're going to distribute to start with. So we're going to take 4 times 2, which is 8x, 4 times 3, which is 12. So my left side of the equation is 8x plus 12. This side, there's no distributing to do, but I can combine like terms. I notice there's a lot of x's. So I have 6 x's here, 1 x here, 1 x here. Add those all up, I'm going to get 8 x's, because 6 plus 1 is 8, plus the 11 as my constant. Again, looking at my conditions, my coefficients are the same, so the 8's are the same, and my constants are different, which in this case is the 12's on this side and the 11 on this side. So again, it doesn't matter what I plug in for x, I'm going to have to multiply it by 8 on both sides, but this side I'd add 12 and this side would add 11. So technically, this side of the equation, the left side of the equation, will always be 1 more than the right side because I'm adding 12 on this side and not in this side I'm adding 11. So again, this would be examples how x would have no solution. There's absolutely nothing I can put in for x that would equal each other. Next we're going to look at, and this one you should be very familiar, this is when you would have one solution. So that's everything we did in learning target 1 over and over and over. So this one, the coefficients are different on both sides of the equation. That's honestly all that has to be. So your coefficients, or the number of x's, are different on both sides. So an easy example here for number 1 would be 4x plus 3 equals 5x plus 7. So notice that the coefficient 4 and the coefficient on the x over here is 5. And when I do that, since they're different, I know that I can solve for an x because I'll end up subtracting 4x off this side, and this will give me 1x, and then it would be a two-step equations that we solved before. So again, the condition is it has to be different coefficients. Another example, let's go 3x minus 5 minus x is equal to 3x plus 10. So as I look at this, I can simplify my left side. I'm going to combine like terms. 3x and a negative 1x makes 2x's. And then I'm going to look at what I have here, and I can see that this side has 3x's, or a coefficient of 3. This side has a coefficient of 2, or 2x's. So I know that when I solve here, if I subtract 2x off of both sides, I'll end up with an x, and I can solve this with a two-step equation method. Last example, for those who have one solution, let's say 6x minus 5 minus 5x equals 3 times 2 minus 4x plus x. So I'm going to go ahead and just simplify as needed. So I'm going to look on the left side here. I notice there's 3 terms. So that means I can make down to 2 terms. And 6x and negative 5x makes 1 little x. And I have subtracting 5. I'm going to distribute. So 3 times 2 is 6. 3 times negative 4 is negative 12x. I add the x at the bottom. Again, still 3 terms. So I can combine like terms again. And negative 12x and a positive 1x makes a negative 11x. I can add my 6. I look at what I have. I notice my two coefficients are very different, which means I have one solution because I could solve for that one variable of x. Last one we're going to look at is infinite solutions, which means I can plug any number in for x and it would make it true. Your conditions are that you have the same coefficients on both sides of the equation and the same constant on both sides. So example here would be x plus 15, I'm sorry, that's 7 plus 15x equals 15x plus 7. Notice that the coefficients are both the same and the constants are both the same. And when that happens, they're exactly the same thing on both sides, which means I can plug anything I want in for x and it would make this solution true. Because you'd take, let's say again, let's plug in that 2. 2 times 15 and add 7. On the side, you'd add 2 times 15 and add 7. And since you're doing the exact same thing on both sides, I can plug any value in for x that I want to. So x would have infinite solutions. Okay, let's look at the next example. Number 2 here, 3x plus 2x minus 4 equals x plus 6 plus 4x. And let's go minus 10. So as I look at this, I got a lot of like combining I can do, combining like terms. I have 3 terms here. I know I can make it down to 2 terms. My two values of x's are alike. I add them together. 3x and 2x makes 5x. Minus 4 equals, I have an x, I have a positive 6, a positive 4x, negative 10. Now it's 4 terms. I can put some of that together to make it simpler. Here's a 1x and a 4x, which makes 5x. I have a 6 and a negative 10, which negative 4. And look at that. We have the exact same thing on both sides, same coefficients, same constants. Has to be infinite solutions. And our last example in this video is 4 times 2 plus 6x equals 8 times 3x minus 1. This one I'm going to distribute. So 4 times negative 2 is negative 8. 4 times 6 is 24x's. On this time, 8 times 3 is 24x's. And 8 times a negative 1 is negative 8. Coefficients are the same, notice. Constants are both negative 8. I can guarantee that's infinite solutions because they are the same on both.